Hello friends, welcome to another lecture of electricity and magnetism, that is lecture number 14. I have given the links of the previous lecture in the description box. If you haven't watched yet, please go through them. Now here in this video we're going to talk about parallel LCR circuit. So if you're new to my channel, please subscribe the channel and support me to grow my channel. And if you think this video is helpful, then share with your friends, hit the thumbs up button and also hit the bell icon so that you get notified when new video will be uploaded. Okay, and when new video will be uploaded, then it will be appearing at the end screen of this video. So now let's start. Suppose we have a LCR circuit. So this is the inductor. Suppose let me write here. This is capacitor with capacitance C, and this is the resistor with resistance R. So, and this is the EMF, applied EMF. This is the source of applied EMF. This is suppose, let me draw here, just wait. E is equal to E naught sine omega t, right? So let us suppose this is a parallel LCR circuit, and total current drawn from the source is suppose I, and current through the resistor is suppose IR, and through the capacitor is suppose IC, and current through the inductor is suppose IL. Let us consider that way. So here applied EMF is E is equal to E naught sine omega t, right? So let it be equation number 1, right? So what will be the current through the resistor? So by Ohm's law, IR, that's going to be equal to E by capital R, and E is nothing but E naught sine omega t by R, right? This is suppose equation number 2. This is suppose equation number 2. Here we have applied Ohm's law, right? So EMF by resistance. Now what will be the current through the capacitor IC? That will be E naught by capacitive reactance, that is XC sine omega t plus pi by 2 plus pi by 2, because we have already studied the AC circuit with capacitor only. So where we had found that current leads in that case, in case of capacitive reactance, AC circuit with capacitor only, IC leads EMF by pi by 2 here. So here we can write, since IC leads EMF by pi by 2, right? So hope you have understood this. So I hope you know these things. This is equation number. Instead of giving the equation number, let me simplify this. So here IC will be E naught by XC sine omega t plus pi by 2, that's going to be cos omega t, right? So this is equation number 3. I hope that you know the meaning of XC, that is capacitive reactance. So now what will be the current through the inductor of inductance L, that is IL. So let me go to the next slide. So here you see, let me draw the diagram here again. So current through inductor, that means IL, that's going to be equal to E naught by inductive reactance, that is XL sine omega t minus pi by 2. And we have already studied that AC circuit with inductor only, the current leaks behind the EMF by pi by 2, right? So here, since IL leg EMF by pi by 2, right? So hope you have understood this, and it can be simplified as, you know, sine, if you take minus common here, pi by 2 plus, sorry, not plus, that can be minus omega t, right? And we know sine minus theta is minus sine theta, right? Is minus sine theta, so it's going to be minus sine pi by 2 minus omega t, and sine pi by 2 minus omega t will be cos pi by 2, right? Will be cos omega t, right? So we can write this E naught by XL. Here we have to write a minus sine cos omega t. So hope you have understood this, how we have got this one. This is suppose equation number 4. And one more thing, let me go to the previous slide. So here you can see, you can replace this XC, here you see, we know that XC is equal to 1 by omega c, so you can write this equation this way. So you can write E naught omega c because XC is equal to 1 by omega c. So I hope you know those things. So now let me go to the next slide. Here again you see XL is equal to omega L. So that's why we can replace this XL by omega L. So here we can write omega L, right? So now what we're going to do, we're going to find the total current. How to get the total current? If you add total current I will be equal to IR plus IC plus IL, right? So let's put the values of IR, IC and IL from equation number 2, 3 and 4. From equation number 2, this is equation number 3, and from 4 we can put those. So from 2, what we have got, E naught by R sine omega t. Then in the next IC, here we have got E naught omega c cos omega t. Then IL is minus E naught by omega L cos omega t. So hope you have understood up to this. So using 2, 3 and 4, right? So here what we can do, we can take E by R common. If you take E by R common, then what you will get, sine omega t, then plus here you will get omega c plus, you will get omega c by R cos omega t, then minus 1 by sorry, I made a mistake here. So that should be, on taking R common, here R omega c cos omega t minus R by omega L cos omega t. That's what we should get, right? So from these two terms you can take cos and R common, right? So, and doing so, what you will get, let me rewrite the same step again. R into, just wait, R into omega c minus 1 by omega L cos omega t, right? So you can write this expression this way. So here, now what we are going to do, so let me write this on the next slide. Let me go to the next slide. Let me copy this first. Okay, so here is the new slide. Here is the last expression that we have got. So now you can see, let us consider that a cos phi is equal to 1, and this constant term b, suppose a sine omega phi, that is equal to R omega c minus 1 by omega L, right? Let me take that way. Then this above equation becomes E naught by R. So here you see there is nothing, means you can consider 1 here, you can assume there is 1. So and doing so, what you will get, 1 is equal to a cos phi. So a cos phi, that is sine omega t, plus this can be replaced by a sine phi cos omega t, right? So using trigonometric identities, what we can write, a sine omega t plus phi, right? T plus phi. So this is sine a cos b plus sine b cos a. You can consider it way, sine a plus b, right? So hope you have understood this. So now you see, let me take this is suppose equation number 6 and this is suppose equation number 7, right? Okay, let me take that way. Then sorry, just wait. Okay, it's fine. And this is suppose equation number 8. Just wait, give me a second. So this should be 5, I think, right? This should be 6 and this should be 7, right? So last equation was equation number 4, right? So this is what we have got. So now you can see, we can evaluate, we can find a value of a from these two equations, right? So how to do that? Let us square by squaring and adding these two equations, equation number 5, and squaring it, then adding with equation number 6, squaring and adding, what are we gonna get? So we're gonna get, so let me write below, a square cos square phi plus a square sin square phi is equal to 1 square on the right hand side, r square omega c minus 1 by omega l whole square. That's what we were gonna get, right? So from here you can take a square common. So let me go to the next slide. Let me copy this step again. So here you see, so taking a square common, we're gonna get cos square phi plus sin square phi. So that's gonna be equal to 1, right? This is gonna be equal to 1. So here 1 square is simply 1 plus r square omega c minus 1 by omega l whole square, and so a gonna be equal to root over, this becomes 1, right? So 1 plus r square omega c minus 1 by omega l whole square. This is the value of a, right? And taking r common, r square can be taken common, and outside the root it will be r. So here 1 by r square plus omega c minus 1 by omega l whole square. That's what you will get. This is the value of a. Now using this value of a here, if you put the value of a here in this equation number 7, so what you will get, right? So let me copy this equation number 7, right? So here is the equation number 7. This is the equation number 7. So just wait. This is the equation number 7. Yeah. Now you see, using this value of a in 7, right? What you will get, if you replace this a by this value, this r will be cancelled with this r, right? So then what you will get, so let me rewrite this equation. So this a is replaced by, just wait. So here you see, now okay, now it's fine. So here this a is replaced by this value r root over 1 by r square plus omega c minus 1 by omega l whole square. by that value, right? So here r are gonna be cancelled. So now our result becomes, so this is the value of a, so our result will be I is equal to E naught root over 1 by r square plus omega c minus 1 by omega l whole square sine omega t plus phi. That's what we will get, right? So E naught, this term is nothing but 1 by z, where z is impedance, right? So E naught by z is equal to sine omega t plus phi, right? So where this is the expression for current, we have got total current, and z is equal to reciprocal of this 1 by r square plus omega c minus 1 by omega l whole square. So this is impedance, right? So hope you have understood this. Now you see, let's find the value of phi. How to do that? So in order to find the value of phi, what we're going to do, we are going to divide this equation number 6 by equation number 5, right? So if you do so, then what will happen? If you divide a sine phi by a cos phi, then you will get tan phi, a will be cancelled, and on the right hand side you will get this r into omega c minus 1 by omega l divided by 1. That's what you will get, right? So that means here phi will be equal to tan inverse r omega c minus 1 by omega l. That's what you will get. This is phi, right? So let me write this expression in the okay, go to the last slide, new slide. So let me write here, tan phi is equal to, what we have got, tan phi is equal to root over, sorry, not root over, r into omega c minus 1 by omega l. That's what we have got. And phi is equal to tan inverse of r omega c minus 1 by omega l. This is the value of phi we have got. How have we got this? Dividing equation number 6 by equation number 5, right? So hope you have understood this, right? Let me copy this, and we will get 3 cases here. So case 1, if phi is positive, so then it will be positive when omega c is greater than 1 by omega l, right? So here you see, so when omega c is greater than 1 by omega l, then value of phi will be positive from this expression, right? If this quantity is positive, then this phi will be positive, right? So that's why here you see omega c is greater than 1 by omega l, so it can be written as omega l is greater than 1 by omega c, right? So you can assume that you have shifted to this, and this is shifted on to that side, right? You can consider that way. Okay, so this is nothing but xl is nothing, omega l is nothing but xl, which is greater than xc. So in this case, current, that is I leads EMF by phi when phi is positive, right? Now case 2. So in case 2, phi is negative, then so instead of writing 10, let me write when. Okay, it will be better. When omega c is less than 1 by omega L, and if you take reciprocals 1 by omega C, then it will be inverted than omega L. So here XC is greater than XL. So if XC is greater, then current lags, because in capacitive reactance, in a circuit with capacitor only, current lags, right? EMF by phi. So now let's move on to case 3, right? So here you see in case 3, omega C will be equal to 1 by omega L. So in that case, this term gonna be equal to 0, right? So in that case, you will get Z is equal to R, right? So this is maximum impedance, right? So because when this term is 0, then you will get minimum denominator. If you get minimum denominator, then 1 by the minimum denominator will give you the maximum value of Z, right? Hope this thing is clear, right? So now let me go to the next slide. Here you see when this is case 3, when omega C is equal to 1 by omega L, right? Or you can write omega L is equal to 1 by omega C, which is resonant condition. So that is X. So if you simplify this, then you will get omega square is equal to 1 by LC. So this is omega is equal to 1 by root over LC. This is the resonant frequency. Right? This is the resonant frequency. And in this case, Z is equal to R, which is maximum. And maximum current will be E naught by R, and the resonant here, let me draw the graph. So here you see, in this case, this is the here this is not INX. This is in this resonant condition. In this circuit, current will be minimum at resonant frequency, at omega R at resonant frequency. This is the frequency curve, this is the current. So here current is minimum. Okay, so hope you have understood these things. If you think this video is helpful, please share with your friends. Help me to grow my channel and inspire me to create new contents for you. And thank you very much for watching this video, and subscribe the channel. Don't forget to subscribe the channel and hit the bell icon. So see you in the next video. Thank you.